Hi guys. So I'm doing another math lesson from home. This one is for lesson 98. In lesson 98 we're talking about scale and scale factor. Okay? So when we talk about scale, we think about things like building a model car or drawing plans for, like an architect draws plans for a building, okay? The model or the plans would be smaller than the actual object that it's representing. But the thing we need to realize is that the lengths of the corresponding parts are proportional. Okay, so we're going to still use our idea of proportions to talk about scale. Okay, so think about something along these lines. A model car has a scale of 1 to 18. So if we have a scale of 1 to 18, that means 1 inch on the model car represents 18 inches on the real car. Okay, so we have model to real, okay, or drawing to real object. Okay, if the model is 10 inches long, how many feet long is the actual car? So we're going to use this information to build a proportion. Okay, 1 is to 18, the relationship between the scale and the actual object, okay, between the model and the actual object rather, it's got to be the same relationship. Okay, so it says that the actual, or the model is 10 inches. In the scale, the model is 1 inch to 18 inches on the real thing. 10 inches on the model represents how many, and then we want to go to feet in the final answer. But let's just go to inches first of all, okay? So 10 times 18 is 180, is equal to L, the length. So we get 180 inches, okay? So typically when we measure the lengths of cars, we don't do it in inches, okay? So we want to convert it to feet. 180 inches times 1 foot to 12 inches, that reduces our inches. And we're left with 180 divided by 12 is 15 feet, okay? So 1 inch on the model represents 18 inches on the car. If the model is 10 inches long, that's going to represent 15 feet for the actual car, okay? Let's try another example. Now again, these examples are different than the examples in your book. So use these examples here. Use the examples in your book to give you some extra practice, okay? A model boat has a scale of 1 to 24. So 1 inch on the model represents 24 inches on the real thing. If the actual boat is 10 feet 6 inches long, how long will the model be? So I just created my ratio box that helps me build proportions. This is a different, it's actually ends up building the same thing. Okay, here we did a proportion, right? Here, I just used a ratio box to build my proportion. So in my ratio box, model, 1 inch on the model represents 24 inches on the real object, okay? The scale is 1 to 24, so that we know that the boat, the actual boat, is 10 feet 6 inches. So I went ahead and converted that to inches, okay, because I have two different units. I said 10 times 12 is 120 inches, plus 6 gave me 126 inches. Okay, so this just allows me to build a proportion. 1 is to 24, as L is to 126. Okay, so I did my cross multiplying, and I got 126 is equal to 24L. So I need to divide both sides by 24. 126 divided by 24 gives me 5.25 inches. Okay, so if the real boat is 10.5 feet long, the model needs to be 5.25 inches long. Okay, so this is what we've been doing, guys. We're just transferring our knowledge about proportions to scale. Okay, now let's move into scale factor. Scale factor. Okay, so when we're talking about scale factor, we're talking about the number of times larger or smaller that the terms of one ratio are when you compare them to the terms of another ratio. Now that's a big, long definition, and it's a little confusing. Make sure you get it in your notes. Pause the video if you need to get it in your notes. But it'll be you'll understand it more when we just talk about what it is. Okay. So far when we've been solving proportions, like this. 3 over 7 is equal to 15 over n. We use our cross products, right? But another thing, I mean, we've done this plenty of times before, is I see, to get from 3 to 15, I multiply by 5. So I do the same thing here, and I get that n is equal to 35. To get from this smaller fraction to the bigger number fraction, the scale factor is 5. We're multiplying by 5, okay? That's what scale factor is. How much bigger are the numbers in this fraction than this fraction? They're 5 times bigger, okay? We can also use this on our similar triangles stuff that we've been doing. This triangle measures 3, 4, 5. This triangle measures 6, 8, 10. Now remember, we need to use corresponding parts. Okay? If I want to know the scale factor, I'm just using SF for scale factor, so I don't have to write the words out. Scale factor from the smaller to the bigger one. If I want to know how many times I'm multiplying to get from the smaller one to the bigger one, I'm going to take one of the side lengths on the bigger one and divide it by the smaller one. 6 divided by 3 gives me a scale factor of 2. This triangle is twice as big as this triangle. I could do it with this side compared to this side. 10 divided by 5 or 8 divided by 4. It's all the same ratio. Okay? If I want to know the scale factor from the larger to the smaller, what's the scale factor from the bigger one to the smaller one? That's going to be less than 1, right? So I would divide the measurement on the small one by the measurement on the big one. 3 divided by 6 is 1/2. 4 divided by 8 is 1/2. 5 divided by 10 is 1/2. Okay? So the small one is half as big as the big triangle. Okay? So scale factor. How many times bigger or smaller is it? Now, one thing we need to think about when we're talking about scale factor is think about a cube. Okay? If we are dealing with a cube, then we're not just dealing with a two-dimensional object, right? So let's think about the scale factor. From this smaller one to this bigger one. This is a 1 centimeter cube. This one is a 2 centimeter cube. Okay? Oh, my phone's ringing. Okay? So if I were to think about the scale factor, this one, all the side lengths measure 1. On this one, all the side lengths measure 2. So the scale factor from the smaller to the bigger is 2, right? The side lengths on this cube are twice what the side lengths are on this cube. But we need to think about what happens to the area, okay? If I were to try to figure out the area of one of these faces on this one, right? 1 centimeter times 1 centimeter, that gives me 1 centimeter square, okay? Now, this cube is twice as big, but look what happens with our area. The area of one of these faces is 4 centimeters squared. So the area is not just twice as big, it's 4 times as big. Okay? Now let's think about what happens with volume. Okay, on this one, the volume of our cube, 1 by 1 by 1, is 1 centimeter cubed, right? On this one, 2 times 2 times 2 gives me 8 centimeters cubed. Okay? So even though my scale factor is 2, the lengths on this one are twice what the lengths on this one are. My area is 4 times on the bigger one, and the volume is 8 times the volume of this one. Okay? So we need to think about when we increase the size of something, what it does to its area and its volume. It doesn't. If we double the size of something, the lengths of the sides, if we double it, the area and the volume are not also doubled. Okay? So we got to be careful of that. Okay, so what I want you to do is I want you to pause the video, go ahead and do A through F on your practice set, and then start your video back up again. Okay, I've had to do the practice set on my little boards because I ran out of big boards. Okay, A. A says, let me grab my book here. A says that we have a blueprint drawn of a scale of 1 to 24, and it says a 6-inch length of a wall on the blueprint means how long is the actual wall going to be. So I said 1 is to 24 as 6 is to the length, the actual length on the wall. 24 times 6 gave me 144 inches, but the question asks for the answer in feet. So I divided by 12 to get 12 feet for your final answer on A. On B says somebody's carving a model ship. Scale is 1 to 36. The ship is 54 feet long. Okay, so here's the scale. 1 to 36, the actual ship is 54 feet long. We want to know how long the model is going to be. So I said 1 is to 36 as L is to 54. I did my cross multiplying here. I got 36 times the length is equal to 54. I've got to divide both sides by 36. Divide by 36. I get 1.5 feet. Okay, but it asks for the answer in inches. Okay, so I said 1.5 feet times 12 inches over 1 foot. That allows me to cancel my feet. So I get 1.5 times 12, 18 inches. Okay, 18 inches for B. On C, we're headed to scale factor, and they give us some proportions, and instead of solving them by using cross products, they want us to solve it by using scale factor. So on this one, I said, well, how do I get from 5 to 15? I multiplied by 3. So I do the same thing down here, 7 times 3, and W is 21. Down here, I see, well, to get from, I have to solve this one, so I'm going to see how do I get from 21 to 3. I divide by 7. 42 divided by 7. X has to be 6. Okay, last two, E and F. On E, it asks for the scale factor from the small one to the big one. How much bigger is the big one than the small one? So I just took the width on this one and the width on this one. I said 10 divided by 4, and that gave me 2.5, 2.5. So this one, the larger rectangle, is 2.5 times the smaller rectangle. These dimensions are. And then they asked us to compare the areas. How much bigger is the area on this bigger one? So I said, well, the area on the big one is 25 times 10 is 250 meters square. The area on the small one, 10 by 4, is 40. So then I just divided 250 by 40. 250 by 40, and I get 6.25. Okay, so even though the scale factor from the small one to the big one is 2.5, the area of the big one is 6.25 times bigger than the area on the small one. Okay? Okay. I know that this scale and scale factor is a little bit hard to understand. You're going to hit it again next year, and you're going to be doing scale and scale factors kind of problems throughout the rest of your math career. So it'll come back. Okay? Okay, guys. Hope you have a great day, and I will see you next time. Bye.